I think so. We'll go ahead and get started. Thank you all for joining us today. We will be recording this, so it will be up on our YouTube channel later this week, along with our media center, which is located on our website, scompetes.org. Thank you all for joining us again. And if you have any questions, we ask that you stay muted the entire time. There is a chat feature at the bottom that you can use to put your questions in, and we will read those at the end, and our speakers will be able to see them too as they come in. So we'll be able to use those during our Q&A at the end. That's about it for me. So without further ado, Suzanne, you want to take over for us?
Absolutely. Good morning, everyone, or good afternoon, depending on where you are. Thank you for joining us today. This is our first webinar series after the summer break. And we're very excited to have our colleagues with us from the Fraunhofer Center for Production Technologies. And, just as a quick reminder, I'm the director of the South Carolina Fraunhofer USA Alliance. We have this alliance set up and we manage this program on behalf of the South Carolina Department of Commerce. It is a dollar for dollar cash match program for companies who are interested in taking advantage of collaborative teams that are made up of Fraunhofer experts, South Carolina-based academic institution experts, and companies here. And one of the topics that we've been hearing over and over and over again as we talk to organizations around the state is that the ability to and challenges faced by companies trying to meet sustainability targets is of utmost priority. So we're really excited to be able to bring not only expertise from the Fraunhofer USA network to this challenge, but also expertise out of Germany. So with that, I would hand it over to Dr. Marcel Schaefer, who's our South Carolina Fraunhofer person, boots on the ground, we always say, and let him introduce our colleagues from Germany.
Thank you, Suzanne. Hello as well from my side. Thanks, Suzanne, for the intro. Welcome back to the webinar series. As Suzanne mentioned, summer is about to end, event season is about to kick in, and as Suzanne mentioned as well, sustainability is one big topic. So we wanted to ensure you have something to say when the big talk is about sustainability when you're at those events, right? So sustainability has been a hot topic in Germany for many years. So it's just about coming to that kind of attention right now here in the state and in the US. So my wish is not only to inform you here in South Carolina about it, but also to bring in advanced technology. So instead of reinventing the wheel, going through a whole development cycle and experiences, again, we want to basically skip that here, piggyback on what's already been developed, and thereby kind of create quick success ecologically, but also equally important economically. And therefore, we have with us today two experts from Fraunhofer IPT in Aachen, Germany, Caroline Hamm and Kilian Fricke. Thank you for joining a webinar series. And let me introduce the two real quick. I met Caro this past July in person for the first time when I visited their impressive institute. And not only the machines there have kind of an engineer's dream, you can also get a real American burger at the cafeteria. Caro is part of the Department of Technology Management and head of the business unit Lightweight Production. She has a degree in industrial engineering with a focus on production technology and management. And focused on her work at Fraunhofer IPT is on industry-focused projects addressing a broad range of sustainability topics. On the other hand, Kilian is part of the Department of High Performance Cutting at the same Fraunhofer Institute in Aachen. He graduated from RWTH Aachen as a mechanical engineer, specialized in aeronautical engineering, such as analysis of manufacturing scenarios for highly complex plane engines. His investigations, of course, focus on performance and economical standpoints, but also looking on the ecological and sustainable point of view. So exactly what we want to talk about today. And I hope we will hear something about that specifically very soon. As always in our series, please hold back with the questions to the very end, put them in the chat. We will address them after the speakers are done with their presentations. So without further ado, shaping innovation in the age of sustainability. Caro, speech is yours.
Thank you very much for the introduction. So can you see my screen?
We can.
Okay, perfect. So then let's start. So yeah, as Marcel already mentioned, our Fraunhofer Institute is focusing on production technology in general. And yeah, we are working together with companies in different sites and different areas, for example, aerospace, automotive, consumer goods, and so on. And what we see in our work with them is that they are facing different issues in a transformation to a sustainable company. For example, there's a challenge of disrupted supply chains, rising energy costs, and so on. You can see different questions, and probably you know some of these very well. But our conviction as an Institute for Production Technology is that it's possible to produce sustainable and green, and at the same time be economically successful in terms of resource and energy efficiency, material efficiency, or recycling, which results in the end in lower costs, of course. So today we want to present you two project examples or two experiences of our project in the area of production or sustainable production. So the first project is our so-called Experience Day. So that's a project that gives the opportunity to explore a self-defined topic in a very short period of time to get insights on trends and what's relevant for you as a client. So in general, we are doing a preliminary study, so you get insights on your scopes assessment at about 10 or 20 trends or fields of interest. And furthermore, you get very individual expert insights and from keynotes for 3 or 4 of these topics, so very detailed information. And of course, there's best practice sharing. So I will detail this later, but to give you an overview first, after this, Kilian will present an extract of a project for energy efficient manufacturing. So this is in the, this is especially about optimizing energy efficient processes, and they were reducing energy and resources, the demand for up to 80% for a milling process. So that's quite a lot. And furthermore, they were working with green materials, so they lowered the dependency on rare and critical materials. And then after showing you two very specific projects, I want to give you an overview of the projects we are working on in general at Fraunhofer IPT in terms of a more sustainable production or 5-step approach for a transformation. And so let's start with the Experience Day. So in general, there are 3 big benefits you get out of this Experience Day. We already did with different companies. So it's a very structured process with a methodical training. So their experts will guide you through the process and give their insights. So you have a very big expertise, or get a very high level of expertise from people from the outside. And third, it's about the best practice sharing. So you will be able to know about best practices, what gives you the opportunity to react and move very efficient afterwards. And so how are we going to do this? So in the first step is about the Experience Day preparation. So what we do there is especially to get to know your goals or the goals you want to achieve. So we kick off with the web conference to get to know the fields of interest that are important for you. And then with this knowledge, we will structure the topics, prepare information, and identify possible fields of interest or trends for you. So we give you a common understanding of the current situation, maybe of different markets, future challenges, possible strategic options, and so on. And after a joint meeting that is in general an online meeting. You can select about 3 to 4 top or key issues you want to focus on, and then we will meet in person at the experience day itself and bring experts and more detailed knowledge in these fields. So, and then after the experience day, first, so I was already one to four. What we will do on the experience day itself. So in the beginning, you get, or insights are set by keynotes in the field of, for example, sustainability, green growth, energy efficiency, or fields for that are interesting for diversification. And then you get very dedicated insights in the state-of-the-art technologies and applications from our keynote speakers, as well as industry experts we invite for this day. And after this first part of the day, we will have some very technical and educated workshops we are doing together. Maybe you know the method of World Cafe. This includes very interactive presentation of the experts in the detailed fields of technology, and this is followed by a joint discussion in the group with your company members. And of course, in the end, we will make an aggregation of the workshop results, and then in the end, after the workshop, it's all about knowledge sharing and supporting you to bring this further. So you will get the documentation of the workshop results with a pre-assessed fields of action for your individual strategic options. And this serves as a basement with for new and validated business opportunities. To sum it up very briefly in some modules. So it's all about your company's targets that you define. We do the workshop preparation, the first step. Then it's the experience day execution. Then we are focusing on the moderation, the workshops. We are searching for interesting keynote speakers, and we will make an aggregation of the results. And then in the next step, that's all about the implementation. So there, we would like to share the knowledge and make a more in-depth exploration. So this was a glimpse of the experience day. So I would like to hand over to Kilian for the second part, the energy efficient manufacturing of turbo machinery parts.
Yeah, thank you very much, Carol. It's a literal handover, actually, as you're right across from me here. So happy to be with you guys here. Good morning to everyone in the US. Kilian Frickel here. So as introduced, I have a strong focus then on the technical aspects when it comes to the quantification of sustainability and efficient manufacturing processes. In this subchapter, I will just give a quick glimpse into one of our main projects that we're working on in terms of sustainability and ecological footprint calculations, and have a very specific or precise example when it comes to the manufacturing of turbo machinery parts. And but before we dive into the actual methodology that we use, let's just go and look at the motivation that's actually behind this initiative and project. So the project I'm working on is called the Clean Sky project, and especially in the past few years, awareness has grown, especially among European countries or in the European Union, when it comes to the ecological and sustainability goals that have been set not only by the EU but also by the UN. And looking at the aviation industry, so this is the specific example, you can see that the revenue passenger kilometers have increased over the past few years exponentially, apart from obviously the dip in 2020, 2021 because of COVID. But experts say this will recover in the next few years and we'll be back on track when it comes to this. And despite all these, or the increase in revenue passenger kilometers, the targets are set, especially in the Flight Path 2050 documents, to say, okay, we need to reduce the emissions during flight per passenger kilometer. But above that, there's not only a focus on the, let's say, CO2 footprint or the what we consume on kerosene and oil here. And so how can we actually also approach different aspects when it comes to sustainability? Because it's not only the use phase within a product's life cycle, it's much more than that. I mean, when we talk about sustainability, we can say we could potentially quantify the monetary aspects by saying, okay, something is very expensive or cheaper than something else. This is a very classic approach by sticking to the classic triangle of cost, quality, and time. So trying to optimize this and being sustainable from this perspective. However, you can see a tendency, this goes in line with the exponential also increase of the use of resources and energy worldwide, to say, okay, it's not only the use case, it's not only the kerosene that we consume during the aviation operations, but it's also looking at the broader scope of the product's life cycle, including the use of green materials. We call them green materials. I'll get back to this in a moment, and the use of efficient manufacturing processes, because this goes in line not only with decreasing the costs of the processes, but also decreasing the environmental footprint of these processes. Yeah, it goes hand in hand more often than not. And this also then includes the ESG factors here. So in addition to the cost, quality, and time triangle, we can see a tendency, not only in this project, but in general, that environmental, social, and governance aspects are highly recommended to be part of sustainability discussions. So in this very particular example that I brought here, as I said, in the Clean Sky Initiative, there's a strong focus on the aviation industry. We here at IPT have a strong focus on the manufacturing of aero engine components, so aircraft engine components, like the blisk, for example. The blisk is one good example. It's a rotor from the engine's compressor. I won't get into a technical detail here what it actually does, but it's a highly complex component comprised of highly complex alloy that's difficult to machine. So a perfect example just to see how different how different actually the process chain scenarios can look like on how to manufacture these different components, and then looking at the hotspot analysis of saying, okay, here are the spots and points where we can decrease the influence on our environment, but also the costs. And this is the example I brought with me today. So looking at different manufacturing processes and process chains for these aero engine components, more specifically the engine rotors here. And if we look at this aero engine rotor, for example, we can see, okay, it's a highly complex component with filigree blades that are manufactured all in one piece. So you just don't manufacture the disc and then attach the different blades to the disc. So it's all made out of one large raw part, actually, and then built and turned subsequently in the different manufacturing processes. And our first step when we want to quantify the economic footprints costs that we have is looking at the overall process chain that lies in front of us. So we start off obviously with the raw material that we use. There's a section within the product's life cycle where we start off with the raw material extraction. So where do we actually get the different alloys from? This is an example for a titanium disc. So we have titanium, but also aluminum and vanadium in our alloy. And how do we actually generate or produce the raw parts? So that's the first step, by starting at the very beginning. What are our different processes that lead us to the creation of the raw part of our product? Yeah, and then we list it up into the different sub-processes, like, for example, casting and forging processes, treatment processes, and we quantify the in and output flows in the first step. It's called life cycle inventory, actually, by just quantifying the amount of energy, the amount of electricity we use, compressed air, resources, and so on. And we move on through the entire stages, or all of the stages of the production here, from the turning processes up until milling and ending with maybe coating processes and measurement processes. So really breaking it down to the specific individual processes, and then quantifying the in and output flows that we have. Once we've done this, we can see, we compare the different processes, and then we break it down to the very particular processes that have the highest impact. So in this case, when we look at the list, so difficult to machine component, but you can easily transfer these results also to other parts, not only of an aircraft engine, but also different industries. So this approach, known as a life cycle assessment approach, actually is always identical. So what we did then is actually look at, okay, what's the energy that's consumed here during the individual manufacturing processes. So from left to right, you can see the same process chain that I've just described in the slide before. And what's very obvious here when we look at the amount of energy that's consumed during the different stages of the process chain is that we have a high amount of energy and also resources, that's not even on the slide here, high amount of energy and resources consumed obviously during the raw part shaping, raw part production. Yeah, so the gathering of the raw materials such as titanium and aluminum, but also the alloy generation really consumes a high amount of energy. So this brings us to the points of maybe increasing the use of additive manufacturing, recycling scenarios, yeah, because if you increase the recycling rate, obviously the amount of resources you need for primary production of raw material decreases. And then also the use of green materials. Yeah? Green materials, what does this mean? I'll get to this in one of the following slides. And then the other part, as you can see with these bar charts, and what stands out are the turning and milling processes, so the central shaping processes of my component. And now after this first hotspot analysis, we can get into the deep dive and see how can we optimize these manufacturing processes and how can we approach the problem with the raw material that we need. And this is the ecological assessment that follows then after this. And this is what we did. So we had a look at the raw materials that we use. And on the bottom left of this slide, you can actually just see a direct comparison of the CO2 footprint or actually the energy. So there's it's actually a linear relation between the CO2 footprint and the energy demand actually of these raw materials that we need to just actually generate 1 kilogram of these raw materials. And if you compare this, iron, for example, it's literally nearly 0 kilogram of CO2 equivalent, because nowadays, I mean, these processes have been optimized and it's quick and fast to manufacture 1 kilogram of iron compared to molybdenum, for example, which is part of different alloys or nickel-based alloys and also titanium. Yeah, they have a higher amount of ecological footprint, often measured in the CO2 footprint, but also energy demand. And this is where we then look at different alternatives of alloys that we use and different raw materials that could potentially loosen or lessen the impact that we have before we even start production, because this is the rucksack that these raw materials bring with them before we even start production, yeah, from a sustainability standpoint. And then obviously really then analyzing the different steps within the process chain. On the top left, we can see the primary energy demand we need for the milling and turning process is much higher than any of the other processes within this specific process chain. Now, I would like to stress once again, this is a very specific process chain. These can differ and change. In other process chains, the turning process may have a higher impact or the measurement. So this can obviously differ, but in this particular example, these were our results. And then we really look at, for example, the milling process and take a deep dive on how could we optimize actually this particular step within the process chain. And we analyze the electrical energy we use, the compressed air that we use, and also the materials used not only within the alloy of the raw material or the workpiece itself, but also the tools and the coolant that we use. Here on the bottom right, you can see that our tools are comprised of high amounts of tungsten and cobalt, for example. And our coolants are comprised of or consist of different acids, for example. Yeah? We could potentially also have a negative impact on the environment. And getting back to the raw materials that we use, this is actually a nice chart that I like to show, a world map, just showcasing where do our raw materials actually come from and our alloys here. And if you just look at this map and, for example, say, okay, we need a lot of cobalt and tungsten, for example, for our milling tools. Yeah, very even generic process that's used in different branches of different industries. We can see that a lot of cobalt is actually mined and produced in Congo in Africa, for example. Yeah, 80 to 85% of worldwide cobalt supply comes from Congo. A high amount of tungsten comes from China, and molybdenum, for example, that we need for our nickel alloys in the aircraft industry comes from Siberia, so Russia. So, and I don't want to get into a lot of details, but looking at these countries, it's not only an ecological problem that we could face here in the next years and decades to come, but also a socio-economic or even political level that these demands and supplies can reach. Yeah, so the resources come from all around the world, and if we rely too much on materials from from countries that are politically unstable or socioeconomically critical, this can lead to a lot of problems. This is also a large part of sustainability. Yeah, it's not only about the monetary aspects. And speaking of that, we have monetary aspects, of course. We have social, socio-economic aspects that are important, in political and governance aspects, but also ecological aspects. And how do we quantify the ecological footprint of a product, for example? And this is where life cycle assessment comes into play. And this is a methodology that gives us the opportunity, after quantifying the in and output flows of resources and energies, to recalculate these in and output flows, the elementary flows. So what do we exchange with our environment into specific equivalents? The most famous one at the minute, for example, is the CO2 equivalent, because it's the basis of calculating the global warming potential that we have with the life cycle or the use of different processes, materials, and products that we create. So as you can see here, what do we see here on this slide on the left-hand side? You can see numerous different steps within the product life cycle, or the generic steps from resource extraction to production, distribution, and use. And on the bottom, you can see different impact categories that give us the opportunity to quantify the ecological impact that we have. Yeah, so the most famous one is the climate change or the carbon footprint impact category, and the other ones are also important, or part of a life cycle assessment, as this slide also indicates. However, especially in the projects that we work on, there's a high focus on carbon footprint and CO2 footprint assessments. And just to give you one example of what this can look like, I brought with me this example of two different scenarios or approaches and strategies for a milling process by just using two different tool solutions. Yeah, so you have the cemented carbide tools, very classic and established way of manufacturing not only aero engine components but different nickel alloys, or ceramic tools. Yeah, the more novel approach here. And by just comparing these two manufacturing processes side by side when manufacturing this blisk, for example. Yeah, so this example, the rotor from the aero engine component, there is a potential of decreasing each and every one of these ecological categories that you can see on the bottom left here. Not only the global warming potential, which indicates the CO2 footprint, but also a lot of other different categories, which obviously then differ in height and relative comparison, depending on the constitution or the composition of the actual process chain. Yeah? So this is a quick overview of what we do. We analyze processes and product flows based on improving the efficiency of processes, the use of green materials, take socioeconomic aspects into account, and perform a life cycle assessment to calculate the ecological footprints that we leave behind. And with that, I would like to hand it back to Carol for the third part.
Okay, thank you, Kilian. So as the last part of our short presentation, I want to tell you a little bit about sustainable in production technology as an overview on the Fraunhofer IPT and in what fields we are working on. So as mentioned in the beginning, at Fraunhofer IPT, we are working with different companies which have very different starting points for kind of sustainable transformation, or that are interested in the topic of sustainability. So in general, we have 5 big steps, and we of course support the points that are the biggest pain points for our customers. And to give you an idea, I will show you now our fields of action. So first is about to understand the challenges. So based on these individual challenges and existing tensions, we can start developing a target image. So and with this target image, there we can we start creating the strategic position where you want to go in the future, and what's your company's vision. That can be, for example, a digitalization strategy, for example, to get your production more digital or things like that. And then the third step is to identify your relevant fields of action, and to get the knowledge in these fields to ensure that the target you set can be reached in the future. So that's about products, processes, or business models. So there we are very free, or we have experts in all fields working on these topics. So that's, for example, let's say business model validation, technology concepts and planning, things in this area. And then the next step would be the design and testing of new products and processes, which is then preparation for the integration into new established or new and established operations. For example, new processes, artificial intelligence use cases, or product prototyping. And then after this step, we are more focusing on scaling up. So then it's about spreading the vision and alternative actions. So after successful piloting, we accompany the industrialization and the scaling, which is a very essential level for, let's say, creating green value and exploiting the potential out of it. So in all fields, we have expertise, or we did already several projects to support an end-to-end transformation. And to give you a better imagination on what kind of project these may look like, you already got to know two of them. I want to give you a little or brief overview. So first is, or we can base it on 3 different pillars. So the first one is about the sustainable value creation. So that are considerations of the entire product life cycle, from the design, production, logistics, and the recycling. So this is about the evaluation of the meaningful key figures and actual costs of your production. And with this knowledge, you create transparency, and you're getting resilience, and it generally improves your competitiveness. So the second pillar, then we are focusing on resource savings in manufacturing, in processes, and the complete process change. So this is about making data in production processes accessible for analysis. So this is not always there in every company. So there it's about creating a basis for weighting alternative production technologies, for example. And there our aim is to reduce material and the energy consumption, which results in lower cost in the end, or replacing harmful materials with more environmentally friendly ones. And then the third pillar is about environmentally friendly products. There our point of view is that products are sustainable if they can be manufactured and repaired using fewer resources, and are very and when they are energy saving or low, or have low emissions in the application. So that's the field we are looking on in this pillar. So in the following, I will drill down the field and show you some examples, but I just want to make it it's a very brief overview to give you some glimpse. First for the sustainable value creation, for example, to give you some examples for the key figures and life cycle analysis. This can be about getting transparency about the impact of manufacturing steps on the life cycle assessment. You already got to know this from Kilian already. And then, it's about dealing with key figures and economic analysis. In this area. Then we have another field in the first pillar, that's the green innovations. So for example, technological diversification. So it's about the expansion of the existing service program of your company to new products and new markets. For example, using something like the Experience Day, and working on disruptive technologies. So there we are supporting the identification of future customer needs, or analysis of competences that for supply and demand. So that's what we are focusing on there, to just point some of them out. And then in the field of resource efficient production, in the first part, the energy and resource saving process in the process chain, I want to pick out the D part, for example. This one is about more stable machining processes for better products. So their colleagues are working on a digital twin framework for machining, which serves as a basis for a sustainable production, or in the field of adaptive robotics, where you can create more safety and quality through a higher degree of automation in the production. In the middle, for material savings, for example, additive manufacturing, for maybe repairing defective components for reuse, or to point out the 5G monitoring of processes, and the third part for a scrap reduction through a real-time process monitoring with using the 5G technology. And then to come to the last point, in the field of green technologies, in the first part, the resource efficient applications, for example, we're working on lightweight production technologies, for example, building hydrogen tanks for mobility applications, or the development of pipes in the field of oil and gas. Or this is about the production processes of battery manufacturing, so that we are doing the process interlinkages for battery cells, or the production of the battery cells, or the use of biomaterials for ecological lightweight construction. So that's a very, very big field we are looking on. And just to point out one of the last pillar, maybe the remanufacturing of batteries. I guess this is one thing we really need to look at for the next years. That's, for example, the repair of batteries for a second use, for a second life. So this is just to give you a very, very small overview of all the projects we are working on in 4 different departments at our institute. And for drill down of more details of all the projects, you are invited to contact me, of course, but otherwise we would use the complete day for having a look at all these projects. So thank you very much. And we are happy to answer some questions if you have some.
Thank you, Caro. Thank you, Kilian. Very interesting topic, and I guess we got a glimpse of a small amount of what you actually do. So, I know there's much work to do, but also a lot that you have already achieved and done within Fraunhofer IPT. I want to open the stage now for any questions that the attendees might have. I don't see any questions in the chat, so if you have written them down and have them right in front of you, now's the time to ask the experts about what you have just heard, or in general about the topic. That's not the case. Typically, it's me to kick off the question sessions, and I do have a lot. Top several questions. So where to start? Kilian, yes. I like that you pointed out that in kind of today's world, sustainability is not only the carbon or the CO2 footprint, but that it goes much broader. Then you showed the life cycle assessment. So can that be transferred to other areas? Can that like areas and like, can we transfer this thing to South Carolina? Can South Carolina companies or based companies order this assessment and or parts of it that are of importance? Maybe they don't want the whole thing because regulations here in this field are still to come, I would say. The question is, how can we benefit here from these things? That's something that you can offer?
Yes, absolutely. So thank you for the question, first of all. To be very precise, actually, that life cycle assessment is standardized. It's a standardized norm, actually, 14040. So there's a standardized approach and methodology behind it. It's always 4 steps. Just to break it down very quickly, you have a goal and scope. So in the first step, you just say, what's the purpose of my assessment or analysis when it comes to this ecological assessment I would like to do. Then in a second step, now I know that I would like to maybe compare different products or scenarios on an ecological level. It's now about, this is what I mentioned, the life cycle inventory. So quantifying the in and output flows, the resources that I use, the energy that I use for my processes. And then the final step, third step, is actually the life cycle impact assessment. This is where I calculate these different ecological footprints in the different categories that I briefly showed. Yeah, one of them is global warming potential, but there are numerous different ones depending on what your focus is. Would I like to perform an assessment on the CO2 footprint? Would I like to perform an assessment on toxicity levels, for example? Would I like to perform an assessment on the resources that I use? This is all possible. This is what we can also then provide. So this is the basis of any kind of life cycle assessment and ecological assessment. So there are different facets here. And then just to make or give you the full picture, the fourth step by standard norm is always the interpretation phase. So we get the results. What do we do with it? Because in the end, you get bar charts. And what do I do as a customer in the industry? How do I actually use these results that I have, especially the ecological ones? And how can I combine this with economical findings, yeah, in economical assessment? So it's bringing together the green and blue, or let's say the ecological and the economical levels together. This is all part of life cycle assessments and what we're working on here. And I hope this partially answers the question. So would you like to should it be more precise?
That answers the question and opens up many others. The first question only for potential customers here in South Carolina. Like how long would that be? How would a project like this look like? Like how many days would this assessment last? Who would actually do that? What is necessary to do that?
That's actually a good question. So it highly depends then on this goal and scope that we set. So is it just one product we would like to assess? Is it a whole factory we want to analyze? 5 different process chains we would like to assess. So it really highly depends on the frame of work or the boundary conditions that we set. But just to give you a quick overview, so a direct comparison of, let's say, a hotspot assessment of different processes or a comparison of different scenarios is a project that can be done within 4 to 6 months, I guess. So trying to gather all the data, then really assessing all the sensitivity analysis and what's behind it, on certainly quantification of data. Once you have the data, it's all about the modeling and then calculating these footprints that we leave behind. So it can be a few months, but it can also, in the case of the Clean Sky project, for example, it could mean a few years also when you look at multiple different scenarios and the full process chain, for example. Yeah, it highly depends. Projects can be performed within a few months. Yeah.
And I assume that your experts are doing this and that they're not kind of it's not an invasive thing for the production of the company. So that this would just be something aside and not where people have to, I don't know, stop the line.
No, something like that. Absolutely not. What especially when working with the industry or customers here, the one stage and the one step where we need some input to perform these levels of assessment here are to say, okay, what's the goal and scope that we set here? Obviously, that's the basis then for the project itself, and then getting some data from the actual production line and processes. You don't need to stop your production line. It's just getting there, and we have numerous also different sensors when it comes to this. So getting there, or just also asking experts, which is also a possibility. Yeah. So not only just measuring the amount of electrical energy or compressed air that we consume, but also just from experience and knowledge by saying, okay, what's the amount of raw material and chips that occur here during these process chains and process lines. So there is some sort of an exchange needed for the basis of the data, but everything after that, this is where we then perform the life cycle assessment and calculate the frequency. Yeah.
So very individual, I suppose. Okay, I want to give you a break. If nobody else has a question, I'm gonna jump on Caro.
Okay.
Okay. So the experience day, also something that you can that you offer to companies, as far as I understood it. Yes. So what are the main reasons? Like when a company approaches you, they say, we want to do this because. Mm-hmm. What would you like? What would be the answer?
For example, diversification. So they know about their competences, and they want to get in new markets and new fields to to shape their own sustainability activities. So it's very in the beginning for the strategic view. So diversification is one point. Or a few months ago, we had a project with machinery, or a builder for machinery tools. And he was curious about where to save energy. So we had to look in very deep, or we made a deep dive in different technologies. So we asked a professor who is active in this field. We had some technological experts from the institute involved, and so on. So it's mostly when companies are searching for new fields, they want to jump on new trends, and they are not sure where to go. So that's often when we do something like the experience day. And it, like Kilian already said, it very depends on the target of the company. So we bring the methodology. So and then we work out different fields or different topics.
So I can see this as a kind of workshop where attendees from the company and your experts and also external experts come together and workshop about, ideate about this topic. Where would that be then? Would that be at Fraunhofer IPT or at the company, or again individual?
Yeah, in general, for the first step, the kickoff and the selection of the first trends, or to focus it a little bit more, we're doing this in an online meeting. That's completely fine for this part. But then for the second part, the experience day itself, there is our advice to do it in some other location, not at IPT and not at the company's facilities. Because then, to come to another room, or let's say room or facility, is much better to get out of your daily stuff and be creative and have more ideas, and to get together all your experts of the company, and that everybody is into this searching or creative process.
So Marcel, I'm thinking that this sounds like one of the business models we have here with the South Carolina Fraunhofer USA Alliance, which is the Rapid Innovation Lab. Mm-hmm. So we could focus Rapid Innovation Labs with experts from IPT for South Carolina companies to help ideate on sustainability solutions.
Exactly my thinking, yes.
Yeah, I like that too.
That's a very good idea. We would love to do some kind of these projects, of course. Mm-hmm.
Yeah, I think it's, a lot of times what we hear from the companies is, there's so many different opportunities to reduce carbon footprint, to reduce emissions, to reach the targets. There's more than one way to get there. And the question is, where's the value proposition? How can you get the most value for your resources invested and so forth? And I think a structured methodology for trying to determine where those valuable opportunities are could be very helpful. So it's good to have an approach like that has a system behind it.
Yeah, that's a feedback we always get from our customers who did this project with us. They always say, okay, that was very good. In our daily business, we would never have come to these insights or these solutions. So they're always very, very happy to do it with someone else from the outside of the company.
Yeah. I did have another question too for Carlin. One of the examples you noted in your last slides were recycle to shorten the supply chain. Everyone on this call knows what the supply chain has been like, no matter what industry you're in, really. It's been, the pandemic started some of the challenges that we face, but then there have been numerous other factors that have played a role in disrupting the supply chain. I think no matter really where you are. So when you suggest recycle to shorten the supply chain, are you thinking about, is that really like a second life circular economy kind of an approach, or did you have something else in mind there?
No, it's more about the second life, what you already mentioned. And of course, it's about having a look at your supply chain in more detail, and maybe have a look what kind of parts can maybe sourced out to another company, or what you can, what other kind of technologies you may use. So it's kind of having a look in detail what other possibilities there are, not to go like another way.
Yeah. So alternatives or redundancy in the supply chain, something along those lines. Okay. Thank you for clarifying.
Yeah, it was very nice. Our institute is quite big, so and we have a very, very big network around other institutes and with a university in Aachen. So yeah, then we have a very big view on different fields and can get back to experts and different kind of topics.
Say the number. How many full-time researchers do you have at Fraunhofer IPT?
263.
All focusing on a specific topic, all with a high degree.
They're all. Everyone's looking at something different, actually.
Yeah, that's what I'm reading.
Right. Mm-hmm. So, but it's all around the topic of production technology.
Mm-hmm. So just to make sure that we're not leaving anything unclarified. So, for companies that would be interested in South Carolina in benefiting from the expertise that resides within IPT, we can help you find the right people. Marcel and I are here for that purpose. Match them up with capabilities here in South Carolina at one of our academic institutions. So we would build a collaborative team of people, experts like Kilian and Caroline or others, their colleagues, and you can apply for matching funding to our alliance. We are more than halfway through the year, but we still have plenty of funding for 2022. So let us know if you'd like to explore this further. We also have plans for the beginning of the first half of 2023. We would like to bring some colleagues over here and do a bit of a road show in South Carolina, where we would make some presentations about some of these capabilities, because we know that the demand is there on behalf of companies in the state to explore different ways of achieving SDG targets and so forth. So we will be not only providing this information to South Carolina industry via webinars and opportunities like this morning, but also in person we're aiming for January or February of next year. So let us know if you'd like to be involved in those, have a meeting while those people are here. We'll be communicating some of those opportunities through our communications team at the council, SC Competes. But I guess I just want to say there's more where this comes from. Stay tuned. And let us know if you have some specific interests based on what you saw today.
Yeah, we
Right.
will send you the slides and that you have some handout. And yeah, I gave an overview of different kind of topics. So if you're interested to drill down one specific topic, just let us know.
Perfect.
Exactly. All attendees and all that have registered. I guess it's an early Monday morning still. Will be able to see the video on YouTube. We'll get the link to it, and we'll also receive a slide deck, a handout of the current topics, so that everybody can review again, and maybe then after coffee have some questions, come to us. Love to work with you on that. Thank you. Thank you, Kilian. Thank you, Caro.
Thank you.
Thanks for
Interesting, important topic. Glad that you've been here. And as I mentioned, maybe see you in person at some point next year.
Yeah, we would be happy to come to the US.
Absolutely. Yeah.
Thank you.
Thank you all.
Thank you.
Bye.
Bye-bye.
Thank
Thank you. Bye-bye.